Welcome back to Fourier Solutions Academy. Don't forget to share our videos, subscribe if you have not subscribed before. At this point, we have over 400 videos. It means you can come here and learn any topic of your choice: mathematics, physics, and chemistry. On this video, I'll be working on the chemistry, on physics, which is progressive wave motion. That is what I want to explain in this video. I think the next video will be problem on that part of progressive wave, and by the end of this video you will understand everything about progressive wave. Don't forget to share and subscribe to the channel Fourier Solutions Academy. Now, when you hear what progressive wave, it means, now a progressive wave is any wave longitudinal that spread out from a vibrating source and move through a medium, transferring energy as it travels. That is what is called progressive wave. Now, at this point, let me use graph to represent what I need to do. As far as the first video, I've explained something like this using illustration of graph, but this is very important. Now, our wave travel in this form. Okay, that shall be wave. Now, this place we call it amplitude. I think you all know that. And this, from here to here, we call it a wavelength, which is called lambda. Please take note of those things. They are very, very important. Since I have something like this, permit me to rub upper part of the board. Permit me. Okay, since I have something like that, okay, I can answer that. I think we all know that y, which is where y is the what? Vertical displacement. Vertical displacement of a oscillation and oscillating wave. Now, wave particle. Okay, particle. Now, and we have my lambda as a wavelength, which I've explained that earlier, and my A is called amplitude. That is what I mean by that. Since I have that, I can now let you to know there are some things that you need to know. Okay, before I hand this, let me put my X. My X is called horizontal coordinates from the origin of the what? Of the oscillation wave. Now, before we end this, let me try to explain what is called lambda. All over wavelengths, which is phases different. This also means phase different of the particle distant from the origin. Distant from the what? Origin. Phase different of the wave of particle at distance x from the origin. Distant s from the origin. Please take note of that very well. Those are the things we need to understand at this point. Now, with this, I can now try to generate some equations, which is those equations. Let's see how the equations comes from, because we'll be using the equation as far as this video is concerned, to solve problems. Now, on progressive wave. Now, look at these equations. Now, the wave can travel either in positive or negative direction. Positive or negative direction. Please take note of that, which is negative. It can be negative or positive x direction. Please take note of that, those things. After a particle t, which is time, is the displacement of the wave. Particle can be what? Represented by the following equation. Look at these equations. Now, look at these equations. Now, I have one. Equation number one. Wave of positive will be equals to, now, a sine of 2 lambda, which is going to be of lambda bracket of x minus vt, and or wave of negative will be equals to a of sine 2 alpha all over lambda bracket of vt minus x. The only thing that will change is the what? The position here will change. When it's positive, it will be x, which is distant, minus 1 velocity time. Why this becomes velocity time when it's divided by minus distance? That is very good. And the next one, 2 of the equation will be equals to, of positive will be equals to a of 2 alpha bracket of x all over lambda minus ft bracket. Now, or of negative will be equals to a of sine 2 alpha. It will be bracket of ft minus x minus lambda. Now, that is pi. We are talking about 2 pi, and you know that this will just switch position. I have 3. There are 5 equations if I should guess. Yes, there are 5 of them. Which of third one of positive will be equals to a of sine 2 alpha. 2 of x all over lambda minus t all over lambda over bt bracket of, or of negative will be equals to a of sine 2 alpha bracket of t all over minus x all over lambda. That is that. And the next one we'll be talking about this, which is of positive, will be equals to a of sine 2 of x divided by minus angular velocity of this, or of this will be equals to a sine of angular bracket of angular velocity minus 2 of x divided by what? Lambda bracket. And the last, which is going to be the fifth equation of this, will be equals to of sine of angular velocity bracket of my t bracket of, or of negative will be equals to a of angular velocity bracket of t minus x all over v. That is just 6. That is all what we need. Please, at this point, take note of this equation very well. Take note of these equations very well. They are so important to what we are about to start on this video. Okay, now, they are so important to what we are about to start on this video. Let me try to define the symbols, to quote what is on this. Okay, now let's try to define. Okay, now please take note of this. Now, equation 1, 2, they are so important. Please take note of. I will explain that later. There's no time. Let me quickly use that. So, okay, now, where this is known as 2 pi frequency, which is called angular speed or velocity. Angular speed or velocity. Now, my F is called frequency of the wave, and my T is called period. We have 2T, which is, this is 1T, this is 1T, which is capital letter T, this is another T, which is period and time. Big T is period of the wave, which is, my small t is the time. It is the time, and my V is wave velocity. Wave velocity. Now, lastly, before, please try to understand that equation 1 and 2, which is the one I've rubbed up, they are very, very important. And don't forget that my T equals to 1 all over F, and my V is equals to lambda IF, and my this is equals to 2 pi frequency. Please take note of this very well from the previous video, which is very, very important. Now, with what I've explained now, let me try to give example, you know, that will illustrate what I've been explaining. Now, look at this problem. Okay, with that, let's try to work on this problem. I think let's try to work on it. At this point, the solution, the equations I stated earlier are so important because we are talking about progressive waves. And let me try to interpret this very well. Now, the first thing you need to know that phase difference of a wave between 2 points. Between 2 points is equals to 2 all over what? Lambda. Please take note of that very well. Is it no? It will be x. Okay, that is very, very important. And my wavelengths. My wavelength equals to is a lambda divided by what? Lambda, which is, what's my lambda? Which is my wavelength is what? 50 centimeter. That is my wavelength. Distant from origin, which is x, is distant from origin is 20 centimeter, which is the distance between at a point, difference between 2 points at a distance of 20 centimeter. Now, what else do we need to do now? I can now say that what? By the formula stated above, which is 2 pi of x divided by what? Wavelength, which is I have 2 pi multiplied by 20 divided by what? Lambda, which is my lambda is 50, which this will cancel this, and I can now say that it will be equals to 4 pi all over 5. That is my answer. We all know pi in terms of degree and in terms of rad. In degree is 180, and 2 pi equals to 1 revolution. Take note of those things. And also my pi is equals to 22 all over 7, or you can call it in terms of degree is 180, and 2 pi equals to 1 revolution. Please take note of those things very, very well. That is the answer to that. Now, let me try to explain another question. Let me try to explain another question. Now, look at this problem. Let's see. Now, look at this problem. The distance between 2 points P and Q along a wave is 0.05 meter. If the wavelength of the wave is 0.10 meter, determine the phase angle between P and Q in the radian. Now, how do I solve this problem? Solution. The first thing I need here is that my wavelength, which is my lambda, is 0.10 meter. That is my wavelength. And distance between P and Q, distance between P and Q, which is, we call it X, it will be equals to 0.05 meter. That is very important. And phase angle will be equals to 2 pi x divided by what? Lambda. That is very, very important, which implies 2 pi multiplied by, what is my x? My x is 0.05 divided by, my lambda is 0.1, which is 0.10. Anyhow you want to call it. Now, since I have that, I can now say that normally, this same thing as I can reduce everything to 5 divided by 100, which is 2 lambda divided by 1 divided by 10, which I have 2 lambda multiplied by 5 all over multiplied by 10 divided by 1. Now I can start dividing. This will cancel this, and this one will be here and here. Now my answer becomes pi. That is my answer. Pi is my answer, because 2 times 5 is 10. 10 divided by 10 becomes what? Lambda, which is 1 lambda. That is my answer. Can you see? It's very straightforward. Before I end this part, let me try to show another problem on this. Okay, because I have to make this video for one of my very good students, Joyce. I think by looking at this, you'll be able to understand progressive wave very well. Now look at this question also. A wave has an amplitude equal to 4.0 meter angular speed. One angular speed 1 all over 3 pi rad per seconds, and phase angle 2 pi all over 3 rad. The distance, the displacement y of the wave is given as, that is what you are looking for, is given as. Now, if I were you, my amplitude, you know what is called amplitude. My A, which is amplitude, is 4.0 meter. Now, my angular velocity, which is equals to all over 3 pi rad per seconds. What else do we need to do here? My face angle, which is my face angle, my face angle will be equals to, we already know that 2 pi x divided by what? Lambda, which is wavelength, which is given from the problem, which is equals to 2 pi all over 3. Now, rad. Since I know that, I can now apply applied equation. Okay, applied equation y equals to a sine bracket of 2 pi x divided by lambda minus angular velocity. Now, which is of positive. Now, of negative will now be y of negative will be equals to a sine angular velocity minus 2 pi x divided by what? Lambda brackets. That is my positive and negative. Now, since I know that, I can now continue by having, what else do I need to do now? Okay, now substitute given values into the equation above. Sorry, I'm talking about above. Now, I want to substitute that. It means my y positive value equals to, now, I'm talking about A. What is my A? My A is 4 sine. What is my, I'm talking about 2 pi x divided by lambda minus angular velocity, which implies 4 sine 2 pi all over 3 minus 1 all over, because my angular is 1 over 3 pi 1 all over 3 pi. Normally, sorry, I made a mistake here. This should be like this. It should be like this. Sorry about that. I think all over 3 pi, and of t. There will be a t here. That is what I mean. Now, since I have that, this will give me 4 3. The LCM is 3, and it will be 2 and t. This is t. I think I'll be having sine bracket of, okay, sine. I can bring out pi all over 3 bracket of 2 minus t. That is very first one. And the second one, it will be of negative. The of negative will be equals to 4 sine angular velocity minus 2 of faces, which is close bracket, which implies 4 sine. What is my angular velocity? It means at this point, I don't need to stress myself. The position will just change. 1 all over 3 pi minus 2 pi all over 3 bracket close, which pi. This is going to be having t. Now, since I have that, it will now be equals to 4 sine. Pi will come outside. It means pi all over 3 bracket of t minus 2. t minus 2. That is just it. That is just what I'm talking about. That is just it. Now, the answers now will now be of this. It means please take note of this very well. The answers will now be 4 sine pi all over 3 2 minus t, or 4 sine pi all over 3 bracket of t minus 2. Now, it means it comes in form of quadratic equation, back to our mathematics days, that s equals to y, s equals to lambda, s equals to alpha, or x equals to what? Beta. Anyhow, that is what I mean. That is all what we need to understand at that point. Now, before I end this part, let me try to show last example that will really help us to understand this very well. Progressive wave. Now, okay, last example that really help us to understand progressive wave very well. Now, look at this question. Now, let me try to work on this question before I end this section. A traveling wave moving from left to right has an amplitude of 0.15 meter, a frequency of 550 Hz, and a wavelength of 0.05 meter. 0.01 meter. The equation described wave is, that is the equation you are trying to work on. Now, look at this problem. It's a very simple one. The first one is the frequency, which is 555 Hz, and the next one is the amplitude. My amplitude is 0.15 meter, and wavelength, which is my lambda, it will be 0.01 meter. And what else? And wave speed will be equals to, which is my v, equals to, which it will be 0.01 multiplied by frequency is 550. Normally, I can write this as 1 divided by 100, divided by 100 multiplied by 550. This will cancel this, which I will be having, it will be equals to 5.5, which is 5.5 meter per second. Now, since I have that, I can now continue by saying that the direction is saying that the direction of the wave stated moving from left to right. Moving from left to right. Because of that, because it is positive traveling wave, it means we talk about what? Substitute into y, which is y equals to a of sine 2 pi all over lambda bracket of x minus vt. Moving from left to right. Now, can you see how important the equations are? Now, I can now say that what else did I need? I have my y equals to, my lambda is 0, with me amplitude is 0.15 bracket, which is going to be sine 2 pi. What is my lambda? Is 0.01 bracket of x minus 5.5t. That is the equation I'm asked to do. If I have something like 2 divided by 0.05, I can write divided by 1 divided by 100, which is 2 multiplied by 100 all over 1, which is 200. It means I can say that y equals to 0 point is positive movement, equals to sine of 200 pi bracket of what is my x. My x is not given, which is minus 5.5 t. That is the equation we are talking about. That is all. That is all. So if time permits me, in this video I will try to explain some things also. Don't forget you are home with Further Solutions Academy. Once again, thanks for watching.